All right, good morning, guys. Hello again, my diehard office hours attendees. What we're going to do today is we're going to look at the the second Google form of the week, which has these questions in it. Okay, so let's just go through them, okay? Because I think out of the 4 questions that are embedded in the Google form, there's maybe one question that we have not talked about directly, and then when we get to it, I'm going to give you some notes on it, okay? All right, so let's take a look at this. Okay, the question here is asking for what is the length of
Are you gonna start recording?
AB? What is the length of AB? So we actually touched upon this concept yesterday, right?
So do we need to record this or not?
Say that again. I'm sorry,
Do
Michael.
we need to record this or not?
It is being recorded right now. You are being recorded.
Oh, okay, I see.
Yeah, you are being recorded. So,
Okay.
Michael, what do you recall from yesterday? What is the relationship between tangents that intersect outside of a circle? For example, what do you think is the relationship between length AC and length AB? What's the relationship between the two?
Aren't they supplementary to each other?
Well, when we talk about supplementary relates to length of lines, or do they relate to angles?
Angles.
Angles. So what I'm asking for right now, Michael, is what is the relationship between line segment AC and line segment AB?
They're both gonna be congruent to each other since
They're going to
both
be
tangent.
congruent to one another. That's right. Kira, you weren't here yesterday, but we were able to establish that the tangents, okay, are going to be the same length. And this is no black magic, right? Because, and Kira, you can see this logically because you are a super logical person, right? If I were to draw a line right down the middle here, and Kira, do you remember what angle is formed between radius and a tangent again?
90 degrees.
It's a 90-degree. So therefore, I have two 90-degree angles there. And what kind of triangles are these here?
Right triangles.
They're right triangles. That's right. These are right triangles because these are right triangles. Okay. And and Kira, what is this length right here?
The radius. And
that's 3. Calvin.
OB is also
Calvin, what is going to be the length of this line right here?
The length?
3.
The length of this radius here. What's that going to be?
Also 3.
Also 3. That's right. This is also going to be 3. So if that's 3 and that's 3, and Kira, one more time. The line that's in red, do you see that? The line that's in red, is that the what is that in the right triangle? Is that a leg or hypotenuse?
Hypotenuse.
That's a hypotenuse. And is it being shared between the two triangles?
Yeah, you can.
It is.
They're congruent because of hypotenuse length.
Exactly. Beautifully said. Okay, so the two triangles are going to be congruent because of hypotenuse leg. All right, so therefore, Kira, what has to be the length of this line right here that's in blue?
4.
It must be 4. And you weren't here yesterday for that, so I'm really proud of you for being able to figure that out. So that length there must be 4. All right, so we're moving on. Everyone got that? All right, so moving on. Okay, so we're talking about quadrilateral bear, B-E-A-R, is inscribed in circle O. The question is, what is the measure of angle R? What is the measure of angle R? Yeah, Kira.
106.
How did you figure that out?
74 minus 180 because the two angles will be supplementary to each other.
That's right. Opposite angles in inscribed in a quadrilateral are supplementary. Hold on. Is my screen refreshing? Do you guys see my screen refreshing at all?
You didn't scroll down.
Yeah, actually, I did. So you know what? It's not
Wait.
refreshing. So give me a second while I back out, and then I'm gonna go back in. Okay.
All right.
So give me a second. I'm going to log out, and I'm going to log back in. Hey, Chris, welcome.
Hi. So it seems I missed the first problem.
It's okay. You're gonna catch up. And see if you can figure it out while I back out of the tablet here. Give me a second.
We're on the first problem, actually, Chris, Kian, and Preston. We're on the first problem right now.
Yeah, well, my first problem was different.
So we just finished this problem here. This is the first problem, right? In the second of 3 forms they have to fill out this week. This is the first problem, Chris.
Oh, I see, yeah.
Okay? Kian, are you there?
Yeah, I'm here.
Okay, cool. Were you able to get the first one?
Yeah. Even if I didn't,
Okay.
I think I'd still be able to figure it out.
Cool.
4.
Preston, you're okay there too?
Which for the first form?
No, for question 1 in the second form.
Oh no, I just joined. Sorry, but yeah, I think yeah.
Okay, so let's we're on the second question right now. Okay, all right. So let's take a look on the second question, and in this question here, Kira just told us the approach to the method to figuring this out. What is the relationship between the 2 angles there that are marked in pink? Kira already said it, but I need to hear it from another person. What is the relationship between the 2 angles that are in pink?
They add 180.
Thank you, Chris. The opposite angles of quadrilaterals inscribed in circles are supplementary. So therefore, the 2 add up to 80. Kian, what would be R as a result of this?
R in this case would be so that would be 106 because
That
that's
indeed
opposite.
Would be 106. That's right. Okay, so it would be 106. So that's question 2. Question 3, guys. All right, question 3.
Oh. I see.
Maybe Preston, can you help us solve this one?
Yeah. So okay. Hold on. Sorry. So we know that. Hold on. Sorry. 1 second.
No problem.
We know that the opposite angles would be supplementary, so they would add up to 180.
Good.
Uh,
What would have to be angle D then in that case?
Hold on. It would have to be 63.
I love that. You got it. This Google Form's a breeze, isn't it?
This one is, yeah.
Okay.
Except for the last one.
The last one here. Okay, so the last one, okay, this last question I'm going to have to give you a little bit of notes on, okay? So check this out. I'm going to put this on pause for a moment, and I'm going to shift over and I'll give you a little bit of notes, a little bit of background information so that we can then solve it, okay? All right, so what I want to do, if you have paper and pencil, I highly encourage you to draw this along with me, okay? So if you have paper and pencil handy, please get it.
Sorry. Hang on. There's a lot of stuff going on. That's why I don't have my camera on.
No problem. So everybody have paper and pencil handy?
Yep.
Okay. Michael, you got? Awesome. Chris, you got?
I have.
Yeah.
Okay. Okay. Here you got? Awesome. Okay. Kelvin, you have?
Yep.
Okay, great. So what we're gonna do, okay, in this circle here, okay, what I'm gonna try to do, okay, is to figure out a relationship between between the angles formed by chords. Okay. So in other words, okay, what I'm gonna try and do, let's say if this is angle A here, and then this is arc B, and this is arc C. I'm going to try to figure out a relationship between these three things, okay? If there is a relationship. That's what I'm going to try and do, okay? So check this out. What I'm going to do now, okay, is in this diagram, okay, I'm going to copy this, and I'm going to redraw it so you can see how I'm transitioning. All right, so now check this out. I'm going to connect, I'm going to connect this with this. Okay? I'm going to make that connection there. And I'm going to draw in, I'm going to make that a dashed line.
Wait, are you actually drawing something in? Because I don't see anything changing.
I am drawing it. Oh, you know what? It's not refreshing. So again, let me pause out and I'm going to come back in then, okay?
Okay. Good morning, Ty. Nice of you to join us.
Hey, morning, Ty.
Morning.
Okay, so this is what I have right now, okay? So, Ty, for you just coming in here, what we're trying to do, okay, in the next couple minutes is to come up with a relationship between angle A, arc B, and arc C. We're going to try to come up with a relationship between angle A, arc B, and arc C. And understand that that angle A is formed by the two chords that we see there. Everyone have this?
Yep.
Okay. And then so in our pursuit, okay, what we're doing is, okay, I drew in those dashed lines in the diagram on the right, okay, which is not a part of the original setup, okay, which is why I drew those dashed lines. So what I want you to do is to answer the following question for me. What is this angle right here in terms of the letter B? What is that angle? In terms of letter B, what must that angle be? So if you're looking at this like it's like crazy and this is like super hard, I want to remind you of this relationship that we had talked about maybe 2-3 weeks ago. And I know this is hard for everyone, but here, so check this out. So I have a circle, right? What is the relationship in this setup right here? How is the intercepted arc and the angle related?
Oh, A is half of B and B is twice of A.
A is half of B, or B is twice of A. That's right, Kira. Thank you for that. So, Kira, having this understanding right now, can you tell everyone else what is this angle going to be? This angle right here? Again, this is the intercepted arc right now, right?
Oh, half of B?
It must be half of B. Thank you, Kira. That was lovely. So this is going to be half of B. This is going to be 1/2 B. And then similarly, right? And I'm going to use red, or actually, yeah, I'll use red. what is this angle over here going to be if
Uh,
this is my intercepted arc?
Have C.
Say that again, Ty.
Have C.
Excellent. This is 1/2. This is 1/2 of C. I love that. Okay, so that's 1/2 C. And wait a minute. We're almost there, I promise you. Okay, so look at this. What is the relationship? What do you think is the relationship between these three angles here? What is the relationship between this, this, and that? Yeah,
Half of B plus half of C equals A.
it is. Ty, how did you know that?
Because we're dealing with a is it a right triangle? I can't really tell.
It's not. It doesn't have to be a right triangle, but Ty, you are absolutely right. If you don't remember the exact name of the theorem, which you are, intuitively applying, so check this out. Check this out, right? Do you guys remember this from school, right? If I have this is A, actually, let's call this A, this is B, and this is C, and this is D. What is the relationship here, guys? Look, what is the relationship between B, C, and A in this case?
Isn't that like A plus B equals, no, C plus B equals A?
It is. It's B plus C is equal to A here, right? Why is that? This is called the exterior
Angle theorem.
angle theorem. That's right. If you need more convincing of why this is the case, right? Why is B plus C equal to A? Well, that's because let's say B plus C plus D. What does that equal to?
180.
And what does A plus D equal to?
180.
So therefore, we can perform a substitution. We can say B plus C plus D is equal to A plus D. And what happens if we have the same things on both sides?
We could just subtract D from both sides, and then we just get B plus C equals A.
I love that, Kira. That's exactly it. So we end up with this. This is the exterior angle theorem, right? So Kira, one more time, and Ty already said this. What's the relationship between the three angles there that are highlighted in green as a result?
1/2 of B plus 1/2 of C equals A.
I love that. You are so good, Kira. So again, 1/2 of A plus 1/2 of B is 1/2 of C plus 1/2 of B is equal to A. And we're almost there, okay? Because the start of this, okay, was we're trying to figure out a relationship between A, B, and C, right? This can be rewritten as C over 2 plus B over 2 is equal to A. Isn't that right?
Mm-hmm.
Are those the same things?
Yeah.
It is. So I can also then rewrite this as saying A is equal to B plus C divided by 2. This is the relationship. Okay, so this is the main takeaway, guys, right here. This is the main takeaway. So I want to move this. It's this thing right here. This is the theorem, okay? If I were you, I would take a screenshot of this, okay? And take extra effort to recall, to remember this, okay?
Can I see the notes for the bottom
Sure,
where it's talking about the exterior angle theorem?
sure. Right here. Here is everything again. Everyone got it?
Almost. Hang on.
How are you, Ricardo? I didn't notice you came in.
Hello, Ricardo. How are you doing?
Got it.
All right. All right. So now, how do you? So now that we have this theorem, we have this formula, right? Let's take a look at this example right here. Okay. So, which angle is our angle A in this case?
K.
Say that again.
K.
Exactly. That's right. So K is like our angle A. Arc FJ is this thing right here, and that is 84 degrees. This is 84 degrees. Whoops. This is 84 degrees. And we have GH is 76 degrees. And we want to know what is HKJ. HKJ. We want to know what is this angle right now. Right? So the only thing is, okay, if you look at the formula that I gave you just a moment ago, the formula looked like this, remember? Where this is angle A, this is B, and this is C. And the formula went like this, right? A is equal to B plus C divided by 2. Are we immediately going to be able to figure out what K is? Guys, are we immediately going to be able to figure out what K is just based on
Yeah.
this?
Yeah.
Not exactly, because if you look at this, okay, angle A here has to be facing angle B and C, or is it going to be like just adjacent to? What do you think?
Facing?
It's facing it. That's right. So what we're doing, okay, or what you need to do is we're gonna need to figure out what is this angle over here first. Okay, what is that angle there? And then from there we can then figure out what the angle K is. Do you see the logic in that?
Yeah.
So Kira, I think you are thinking of something.
84. If you want to find the answer for angle G, we could just do 84 divided by 2, which would be 42, and then we could divide. And for angle F, we could divide 76 by 2, and we get 38. And then when you add the two, you get 80. Subtract 180 from that, and you get.
I
And
love that.
and since I forgot what is the two angles being congruent.
Linear pairs.
I don't think the vertical angles are.
Right. So what Kira said, just to recap again, right? So we're going to find out what this angle over here is first. We're going to call that X, right? X is equal to what's angle B and what's arc B and what's arc C again?
B is half of 76, which is 38.
Right. So 76 and 84 all divided by 2. Right?
Yes.
If we add them up, what's 76 plus 84?
76 plus
160.
84. Yep.
160, right? And what's 160 divided by 2?
80.
80. And
So
then we
therefore,
subtract
what
180 and 80, and then we get 100.
Yep.
The answer is 100. That's right. So HKJ must be 100 degrees. There you go.
Wait, just to be sure, the answers, like, in order from 1, it was 4, 106, 63, and 100, right?
I don't remember. Hold on. Let me see here.
Okay.
The first one from the very, very top, it was 4. Second was 106. And then it was 60. It was 63. And then 100.
Okay, thank you.
Okay. All right, I'm gonna hit stop recording.
That was a short session.